Okay, welcome friends. Today our topic is armature reaction. So before we discuss the armature reaction, we need to some basic construction details. So what is the basic construction details? In DC generator, we discuss the DC generator. The basic parts are one is stator, construction part, stator and rotor. Stator and rotor. Stator in place of field winding. Field winding is placed on stator, which case they are the DC generator. Don't forget it is a DC generator. We are completely concentrated concept as we discussed the concept of DC generator, and similarly rotor. Rotor is consisting of armature winding. Field winding and armature winding. And field winding it creates some current, that is field current IF. It creating the current, that is armature current. Then after we discuss something MMF, magnetomotive force. We know the magnetomotive force. What is the magnetomotive force? Magnetomotive force is nothing but number of conductors into current. That is a MMF. Here also field winding consisting of number of conductors, armature winding consisting of number of conductors. Due to these two effects, conductors and current, these two effects, the resultant is the magnetomotive force. It is the resultant magnetomotive force in field, and similarly magnetomotive force MMF in armature. So when MMF is created, it's created the some flux, field flux and armature flux. This is the field flux and armature flux. Field flux and armature flux. Now coming to the armature reaction. The armature reaction is nothing but effect between them. The effect between them, like pi of field flux versus armature flux, or MMF in field versus MMF in armature. So these are the armature reaction, the effect between the stator field and rotor field. The stator field consisting of what are the resultant? Field flux and armature flux. The effect of field flux and armature flux, that is nothing but the armature reaction. We can also call as the effect of MMF of field and MMF of armature. That is nothing but the armature reaction. Now coming to the what are the effects of armature reaction? The armature reaction effect of armature reaction basically two effects. One is demagnetization effect and cross magnetization effect. So how to come the demagnetization effect and cross magnetization effect? Before we study the basic operation of DC generator. So in basic operation, let us that is the stator part, north pole and south pole. Okay, and in center is the rotor part. In rotor part as consisting of number of conductors. Rotor part consisting of number of conductors. Okay, and what happened to north pole and south pole? These are the magnetic poles. The magnetic poles, some magnetic lines passing through here. Magnetic lines is passing through here. Okay, and magnetic lines is passing through here. When it is the magnetic lines are passing through here, the center point we are taken to the O, and we represent the magnitude and direction. So these are it is represent the magnitude of direction of main field winding. These are the main field. So main field direction and magnitude, that is nothing but OFM. Main field MMF, magnitude and direction. So let us some points here. We discuss the two more points. One is GNA and MNA. I think we know GNA and MNA. We know the full form. GNA is nothing but geometrical neutral axis, and MNA is nothing but magnetic neutral axis. Geometrical neutral axis and magnetic neutral axis. Now, where it is based off GNA and MNA. First, we are taken to the GNA. GNA bisecting line. What is the ZNA? ZNA is a bisection line. Bisection line in between the poles. In between the poles. So what are the poles here? So one is north pole and south pole. Two poles will be there. So the bisecting line. These are the bisecting line. So this is called bisecting line. So at the middle, bisecting line in between the two poles. So this line is nothing but we are consisting of GNA. This line we are consisting of GNA. Similarly, now we discuss the MNA. MNA is nothing but magnetic neutral axis. Magnetic neutral axis. The magnetic neutral axis is nothing but it is perpendicular to the main field axis, perpendicular to the main field. So where it is the main field? So for example, these are the main field is passing from the north pole to south pole. So what is the perpendicular we are taking? For example, these are the north pole to south pole, some axis. So we are taking to the perpendicular exactly 90 degrees to the axis. So here also same as it is the perpendicular axis. At the point we are taken to the perpendicular axis. So both are in. It is a perpendicular axis. So if it change, if in case, so main field axis will be changed. For example, main field axis will be changed. For example, main field axis will be changed automatically. MNA also shifted. So note this point. If it in case of main field axis will be changes, automatically MNA axis also changes. MNA also shifted. Okay. Now initially at initial condition nothing but at steady condition. At steady condition, what happened? Both MNA and GNA are same axis. Both MNA and GNA are same axis at steady condition, nothing but at the period of starting condition. Let us now here we are consisting of completely we are discussing about the DC generator. So DC generator, it is rotating some direction. So here moving direction. This is the moving direction. Some moving direction. Let us here we are taken to the conductors. So conductors are some armature conductors are related to the north pole and some armature conductor is related to the south pole. Now the flux is passing from north pole to south pole. The flux is passing from here north pole, we are taken to the direction north pole to south pole. The flux is passing from north pole to south pole. Let us now according to Fleming right hand rule. What is the Fleming right hand rule? Three fingers or whatever it may be, they are the right, this is my right angle, three fingers are perpendicular to each other. Three fingers are perpendicular to each other. The thumb indicating the motion of the conductor, and what is the forefinger? Forefinger indicates the magnetic field, and these are the induced EMF. And middle finger is indicating from the induced EMF. So this right hand rule applicable from here. So now here magnetic lines of force passing from in this here. So whatever the forefinger, we are consisting of forefinger, the thumb, and forefinger, middle finger. So thumb indicate motion of the conductor. Here motion of the conductor from bottom to top. It is rotating from in this direction. Okay. So field will be going from in this direction. So automatically current is entering. Current is entering to the conductor. Current is entering to the conductor from this direction. So motion of the conductor and magnetic field, current is entering direction. So let us, thumb is here, motion of the conductor, motion of the conductor. So which direction? It is moving from the clockwise direction. Clockwise. And similarly, F forefinger is the magnetic field, main field. We are taken to the which is field, that is the main field axis. Main field axis. So whatever the middle finger is current, induced current, that is here entering current at starting, entering current. So these are applicable where it is on north pole region. North pole region. Armature winding, but in north pole region, where it is air entering. Okay, let us now coming to the south pole condition. Same again, we are go to the south pole condition. We are consisting of four fingers, thumb, motion of the conductor. Sorry, forefinger. So let us thumb, forefinger, middle finger. Thumb, forefinger, and middle finger. Now here, what happened here? The rotation is reverse, downward direction. Here same clockwise direction, but here upward direction. Now coming to here, downward direction. So these are the simple thing: upward direction, upward. So here downward direction. Similarly, motion of the conductor. M is the motion of the conductor. Same thing, motion of the conductor. Motion of the conductor. It is same as clockwise, but downwards. Downwards. Let us. F is no change. F is the main field. Main field. Now we are taken to the middle finger. There is a problem. Middle finger. So now coming to the magnetic field lines here, motion of the conductor from the downward side, automatically the induced current is outward direction. Here inward direction, entering current, and nothing but here inward direction, inward, here outward. Outward current direction, where it is a outward current direction, that is indicated with the dotted line. So here indicated with the cross line, here indicated with the dotted line. So this is occurring where it is. So this phenomena occurred in on south pole. This phenomena is occurred in on south pole. Now let us here. So north pole to south pole, magnetic field is clear. So some cross lines and dot lines on the armature conductors. So we discussed the GNA and MNA also. At steady state condition, both are in same axis. Now let us. It start with the rotation. When it is start with the rotation, what happened? When it is starting with the rotation, I think this is. When it is started with the rotation, okay. When rotation starting, rotation, when it is starting with rotation, when start with rotation. Rotation is starting, the rotation is always flowing from here, clockwise direction. So we are consisting of some points. So from here, starting point, when it is the starting point, it is indicating with leading tip. So these are the trailing tip, trailing tip, and this is also lead tip and trailing tip, trail tip, leading tip, trail tip, trailing tip. So leading tip, trailing tip, leading tip, trail tip. Let us now it is moving some direction. Now, whatever the armature flux, whatever the field flux, now field flux is passing through the straightward direction, but into the armature field direction. Due to armature winding, it is armature current flowing through the armature conductor. So armature conductor also it creates some own flux. Armature conductors also it creates the own flux. So what happens? This flux is it is they are entering the according to thumb rule. Thumb rule. What is the thumb rule? What is the thumb rule? So thumb rule is nothing but entering current. Whatever the thumb indicating the current direction, and remaining four fingers there is a field direction. So remaining, what is the thumb? Thumb indicate the thumb rule. Thumb indicates current direction. And remaining four fingers, that is four fingers indicates the field. Which field? Conductor field due to current. So that is a field direction. It is indicated with the field direction. Now let us here it will be some direction will be there, entering and downward direction. Okay, here which direction? It's flowing from the downward direction. So these are which are, this is nothing but the armature. This is indicated the which is OFA. What is this? OFA is nothing but MMF and magnitude. MMF magnitude and direction of armature MMF. So here armature MMF, what happened? Which direction? The direction is the downward direction and exactly 90 degrees perpendicular to the main field MMF direction. So we are taken to the here MMF direction. So these are OFA. I think OFA. FA direction. FA direction. Okay. Now here also in dotted lines output anti-clockwise. They are the clockwise direction. They are the anti-clockwise direction. From now we can observe they are the center point and consisting of the 2 points. So let us these points are we are taken. So we divide the axis. This axis is nothing but the interpolar axis IP. So this axis we are taken to the polar axis. Let us consider this axis is nothing but the interpolar axis. At steady state condition, GNA, MNA or interpolar axis are all are in same axis. So main field flux at steady state, that is the polar axis. When it is starting with rotation, we discussing from here leading part. From here to here, uniform air gap. This gap is uniform air gap. It is uniform uniform air gap at point. So what happened? This point here we are taken to the some points lead to trail part, tail, tail part, lead point and tail part to what happened? The flux is uniform air gap flux. Uniform air gap. What is the uniform air gap? What is the armature flux? The armature flux, pi a is the armature flux. Armature flux is directly proportional to the MMF, magnetomotive force of the armature. So there is no change of the force sign. So both are armature flux and field magnetomotive force is directly proportional. So now next as tail port to interpolar axis, IP. Tail to interpolar axis. So interpolar axis, what happened here? The length will be increased. Which length? Air gap length will be from in this direction. Air gap length is increased. When it is the air gap length is increased, we know the some formula, reluctance. Reluctance is equal to MMF by flux. MMF by flux. And also the reluctance is equal to the basic function of reluctance. Reluctance depends upon the parameters L by mu naught mu r A. Reluctance is mu naught mu r A. So we are taken to the reluctance is directly proportional to the length, air gap length. When air gap length will be increased, reluctance will be increased. When the reluctance will be increased, the flux will be decreased. At the condition, what happened? Therefore, armature flux pi a, armature flux is reduced. Armature flux is reduced. Now, last case, interpolar axis to lead pole, lead tip, tail tip and lead tip. So let us lead tip, what happened here? From here to here, from in this part what happened? Air gap length is here increased, here air gap length is decreased. When air gap length is decreased, automatically same condition will be applicable here. Nothing but reluctance is directly proportional to the air gap length. So air gap length is decreased, automatically reluctance will be decreased. Then after the flux will be increased. So from the resultant, pi a is increased. So pi a is increased from the case. Now we can observe final conclusion. So armature flux, we discussed about the only armature flux. Armature flux is maximum. So here pi a is maximum at maximum, nothing but increased. Increased at in which direction? At a leading pole tip. At a leading pole tip. Leading pole tip. Next, pi a is minimum at a trailing pole tip, trail pole tip. Leading pole tip and trail pole tip. So we can observe. So here is weak. For example, where it is a leading pole tip, armature flux is strong. Armature. So armature flux and leading pole tip is strong. And main for what is the here trailing pole tip armature flux is minimum. So what happens when the main field is passing from north pole to south pole, here is the strong. Armature field is strong. Here armature flux is here strong, armature flux is here weak. Automatically the strong flux is shifted to the strong, due to the strong armature flux is pushed to top side of the main field flux. Then after automatically the main field flux direction will be changes. So how to direction will be changes from the case here FM from the direction and OA is the perpendicular direction. So whatever the resultant, due to this effect, the resultant flux is resultant direction is as per the parallelogram law, it will be changed in the some resultant. So the resultant is nothing but we can change the shift of the MNA. Listen careful. When it will be strong armature flux, it will be weak armature flux, magnetic flux. So main field flux is passing through here. In previously steady state in straight line will be passing through the line. When it is will be strong magnetic field, it will be shifted, it will be pushed to top side. So most of the main field winding is passing from the top side. So top side to again trail side, and here also strong, here also strong. So here also armature field flux is strong, here also armature field flux is strong. So these two are shifted to the opposite side. Opposite side is nothing but weak armature flux side. So then after automatically main field flux is shifting to the weak side. So where it is a weak side? So from the main field flux is completely shifted to here. Therefore, main field length is passing from some change the direction. Main field flux, we can change the direction. Main field flux, then change the direction. Not exactly in the straight line. In previously exactly straight line. Now it is we change the direction. When it will be changes, main field axis will be changes. What is the MNA? We know the MNA. MNA is nothing but the perpendicular axis of main field axis. When it is MNA automatically in the previous case main field axis is exactly some horizontal line, so it is a perpendicular line. But here we can change the direction automatically, it will be shifted to the some axis. Automatically what happened? MNA is perpendicular to the main field axis. What is where it is the perpendicular? So in this case it will be these are the perpendicular axis. So therefore MNA is shifted to some angle. So in perpendicular axis, MNA shifted to the some axis. These are the MNA new MNA, because of when the main field flux direction will be changes, MNA also change the direction because of MNA is always perpendicular to the main field axis. Okay, I think it's clear. Next, so what happened here? Leading pole tip and lagging pole tip. We can observe. Okay. So let us at a leading pole tip. So main field flux is maximum. Previously we discussed the armature flux, but now we discuss the main field flux, that is the resultant flux also. Main field flux also resultant flux. So now main field flux is maximum at a trailing pole tip and minimum at a leading pole tip. Where it is the maximum, so where it is a minimum, that is a demagnetization effect. Demagnetization effect. At leading pole tip is demagnetization effect, and at tail pole tip is maximum field winding, that is a magnetizing effect. These are DC generator concept. Listen very careful. In previously we discussed the armature flux. Now we discuss the based on main field flux. Main field flux in maximum at in tail pole tip. So maximum at tail pole tip, that is nothing but the magnetization effect. Where it is the minimum. So minimum is nothing but, so main field flux is some effect on some saturation effect is occurred into the leading pole tip. At the condition the magnetization is demagnetization effect. So these are the based on main field. So we can write this. So we can write this main field flux. main field flux. So main field final resultant flux is the main field flux only. Okay, so these are the DC generator. We can similar kind of we can write of DC generator, sorry DC motor at lead. Lead is magnetization effect, and at tail pole tip is demagnetization effect. So these are DC motor. Because of DC motor and DC generator, the direction will be current direction will be changes. Okay, here voltage and current in same direction. Here V and I is opposite direction only. Opposite direction. V and I. V and I. Generator is the same direction, motor is the opposite direction. So leading pole tip is the magnetization effect, and trailing tail pole tip is the demagnetization effect. Okay. So effect of armature reaction. From the case of, we can find out some effects. So what are the effects of armature reaction? We discuss the effect of armature reactions. Effect of armature reaction. So what are the effects of armature reaction based on the two effects? One is demagnetization effect. Demagnetization effect. Another one is the cross magnetization effect. Second one is the cross magnetization effect. First we discuss some basic things of the demagnetization effect. So demagnetization effect, what happened? The main field flux will be reduced. Where it is a lead pole, demagnetization effect, main field flux is reduced. When the main field flux will be reduced, automatically the induced EMF is reduced. So due to effect of saturation effect, why it is the effect of? That is effect of saturation. Effect of saturation. Next one is cross magnetization effect. Cross magnetization effect. What is a cross magnetization effect? Cross magnetization effect. So what is cross magnetization effect? So cross magnetization effect, we increase the maximum flux. So let us increase the flux, increase the main field flux. So therefore automatically the induced EMF is increased. So due to increased, the cause of insulation failure. Insulation failure. Again, so due to the cross magnetization effect, some circulating current will be passing. Circulating current will be passing. So due to circulating current, what happened? The effect, sparking effect is occurred, or arcing effect. Sparking effect is occurred at brushes. So another one note point, brushes. So brushes always in place of MNE axis. So brushes always spaced on MNE axis only, based on MNE axis. Brushes always in space of MNE axis. Okay, so these are the some effect. So now detail how to come the effects of demagnetization effect and cross magnetization effect. Let us we can consider. So now at the direction, now coming to here, maximum maximum field flux and tail pole tip, minimum field flux and leading pole tip. So it will be starting with rotation. When it is starting with rotation, due to the resultant force, as per the parallelogram law, MNE is shifted to the some angle. MNA is shifted to the some angle. So the angle is some, automatically theta is equal to, we are taken to the theta angle is equal to 30 degrees. When it is shifted to the some angle, MNA is the new axis. When it is the MNA is shifted to the new axis, here it creates the two losses, that is two effects, demagnetization effect and cross magnetization effect. If it in case of, if theta angle is 0, where it is a 0, only one effect, that effect is demagnetization effect. It is rotating with some angle, so two effects will be occurred. If it in case of steady state condition is 0 position, angle is 0 position, that is, in that case of only one effect is occurred, that is nothing but the demagnetization effect only. Now it is shifted to the some direction. When it is shifted, automatically, which one? Again, now let whatever the poles on main field winding poles. Okay, so armature conductors on north pole, armature conductors on north pole is shifted to south pole. Again, the south armature conductors on south pole shifted to north pole. It is shifted to north pole. Nothing but here armature conductor. This armature conductor is shifted to here. So again, this armature conductor shifted to here. When what happened? Automatically the armature OA. So direction of MMF of armature flux also we change the some direction. What happened in this case? Exactly perpendicular axis. But now it has taken some axis. So these are the OFA is nothing but MMF and direction of armature flux. Armature MMF. So direction and magnitude and direction of armature MMF. So what is the direction of magnitude? So due to this effect, it will be shifted to the again some axis, that is OA. That's the O point. Okay. Now we are taken to the previously first we draw the parallelogram law. So here also resultant. First we can draw the resultant here. But previously we draw the two axes, then after we draw the resultant. But here already some resultant will be occurred. The resultant direction. Whatever the two direction, this resultant is effect on due to 2 points. One is this resultant effect on 2 points, that is a OFC, that is a cross magnetization field, OFD, that is a demagnetization effect. So cross magnetization effect, demagnetization effect occurred based on rotation of the shifting, the simple thing, it is shifting the MNA. MNA will be shifted automatically, angle will be changes. When angle will be changes, two effects will be occurred, that is demagnetization effect and cross magnetization effect will be occurred. So in demagnetization effect, exactly opposite to the main field winding. Demagnetization is exactly opposite to the main field and cross magnetization is perpendicular to the main field. So what happens? Demagnetization always to reduce the main field winding. Demagnetization is always to reduce the main field winding. That case of demagnetization to reduce the induced EMF. But cross magnetization to disturb the main field winding. To disturb the main field winding, automatically we increase the armature reaction. Armature reaction will be increased. We can add this few points. So cross magnetization what happened? Disturb the main field main field flux, disturb the main field flux, automatically what happens? The armature, that is nothing but the cross magnetization effect. So what happens here? The armature reaction will be increased. Will be increased. Now FD, we can add a FD. So it is it is opposite to the, opposite to the main field flux. Main field flux. When it is opposite to the main field flux, it is reduced to the, it is reduced to the main field flux. When it is reduced to the main field flux, automatically, therefore, in EMF will be reduced. EMF is decreased. EMF is decreased. There is a demagnetization effect. So, why is the EMF is decreased? Already we know the saturation effect. We know the saturation effect. That why this EMF will be reduced. So, FD and FM. So, let us. So, to overcome the shifting angle, we need to connect some interpolar axis. When it is we are connected to some interpoles or compensated windings, in large machine we are connected to the interpoles and compensated winding. So it is compensate the cross magnetization effect, where it is a maximum EMF, armature reaction is maximum in cross magnetization effect. Where it is a cross magnetization effect, armature reaction is maximum. To reduce the armature reaction, we need to connect the interpoles or compensated windings. So those the case of interpoles or compensated winding. To opposite to the, where it is a, in this case we are formation of cross magnetization effect. So due to the cross magnetization, opposing flux will be produced. So due to the opposing flux, to cancel to the main field flux, automatically to reduce the armature reaction. That is, will be discuss the interpole and compensated winding topic. So now we discuss the demagnetization effect and cross magnetization effect. Now let us demagnetization effect and cross magnetization effect. Okay, first we discuss the demagnetization effect. Demagnetization effect. We need to find ampere turn. Demagnetization effect, ampere turn per pole. We need to find out the equation. This equation we can find out. Here, demagnetization effect. What happened here? Armature conductor shifting to north pole, conductor shifted to south pole conductor shifted to north pole. So here some flux will be occurred. Okay, so into the clockwise direction, these are anti-clockwise direction. Where it is a demagnetization effect is occurred in this case. So main field flux is passing from. So main field flux is passing from in this direction. We know the main field flux. So armature conductor flux is passing through opposite direction. So both are in which direction? Already we know OFD. Opposite to the main field flux. Automatically flux will be reduced. EMF will be reduced in demagnetization effect. Here also in this direction, but flux will be passing from in this direction. So these are the both are in opposite direction. When it is the opposite direction, what happens? EMF will be reduced. So now we are taken to the cross magnetization effect. Demagnetization effect, sorry. At this region, these are the O point. A, B, C, D, E, F, this point. We are consisting, just we can draw. Only armature. GNA axis. So MNA is shifted. A, B, C, D, E, F. These are the zero axis. So total angle 360 degrees we are taken to the mechanical angle. So total angle 360 degrees. Let us taken as Z is equal to number of conductors. That is I is equal to, I is nothing but when the load will be increased, I will be increased. When the load will be increased, automatically demagnetization effect and cross magnetization effect also increased. So due to the demagnetization effect, cross magnetization effect based on load current also, depends upon the current also. So what is the I? I is nothing but the current in each armature current. I is current in each armature conductor, each armature conductors. Let us I is each armature conductor, like as IA by 2 for lap winding, IA by P for wave winding. Sorry, these are the wave winding, these are the lap winding. Nothing but here generally IA by A is nothing but the parallel paths. Parallel paths. A is equal to 2 for wave, A is equal to P for lap. I think we know windings concept. Next, so okay, next angle theta. Sorry. Okay, demagnetization effect. Theta m, forward leading mechanical angle. So from the case where consisting of total, so demagnetization effect occurred in this path only. So mechanical angle, these are angle. So these angles. From total above triangle, so from above triangle AOC and DOF. So total complete axis is 360 degrees. So how much part will be demagnetization effect? 1, 2, 3, 4 parts. 4 into theta m. Okay, 4 into theta m. So these are the total. Only we are taken to the how much axis will be occurred. Into the demagnetization effect? 1 by theta m by 360 degrees. Now we are consisting of, in this case, some armature conductors will be there. So total armature conductors into the angle. Total armature conductors into the angle is nothing but, so 4 theta m by 360 into what is total armature conductors. Armature conductors is equal to Z. So again we can find out turns. So we need to ampere turn. So each turn is equal to 2 conductors. Already 2 conductors. Let us total ampere turns into the angle. So ampere turns into the angle, nothing but, so each turn is equal to 2 conductors. Already 4 conductors. We can turns into turns. We can write turns concept. So nothing but 2 theta m by 360 into Z. So next, total armature turns. So again, total armature turns in ampere turns. Total armature ampere turns per pair of pole. So these are, we are taken to the pair of pole only. So because of only two pairs, so we are taken pair of pole theta m by 360 into, we are taken to the ampere. So Z into I. So we need to find out armature reaction. Ampere turn, ampere turns per pole. Each pole, we are taken to the pair of poles, we are taken two poles, but we need to the only single pole, so that is case of 2 will be cancelled, theta m by 360 into z into y. So these are the demagnetization effect. Demagnetization effect formula. What is the formula? Theta m is equal theta m z I by 360 degrees. Here theta m is equal to mechanical degree. The forward lead to the mechanical axis. Again we discuss the similar concept of cross magnetization effect. So let us discuss the cross magnetization effect. Let me discuss the cross magnetization effect. Remaining all will be same, but cross magnetization effect is occurring in this axis. This axis will be occurring to the cross magnetization effect. Cross magnetization effect. Cross magnetization effect. At the period of in this axis we have discussed the cross magnetization effect. So we know the total ampere terms we have taken off. Okay. Total armature conductor per pole is equal to Z by P. Total armature, the total armature conductor per pole is equal to Z by P. Now demagnetization effect to conductor per pole is equal to, what is the demagnetization conductor per pole? So the demagnetization conductor per pole is equal to 2 theta m 360 into z in z. Only conductor per pole only, not we are taken to the ampere turns. Let us now we can find out the cross magnetization effect. Cross magnetization conductor per pole is equal to, so output, simple thing we can find out the, so summation, these are the total sum minus this one, we can find out the cross magnetization effect, nothing but Z by P minus 2 theta m 360 into Z. We can common Z 1 by P into 2 theta m by 360. Cross magnetization effect. Now let us cross magnetization effect ampere terms. Ampere. So when it is taken as cross magnetization ampere conductor per pole, for example ampere conductor per pole, so nothing but Z is equal to Z into ampere, we are taken to the I, Z I by 1 by P minus 2 theta m by 360. 2 theta m by 360. Again let us, they are the ampere conductor, but we need to cross magnetization in turns. Cross magnetization ampere turn per pole. Ampere turn per pole we can take as Zi by 2. We are taken to the by 2, 1 by 2p minus theta m by 360. 1 by 2t minus theta m by 360. So this is nothing but ampere turn of cross magnetization per pole, that is equal to Zi 1 by 2p minus theta m by 360. What is the theta mechanical axis? Theta mechanical axis is equal to p by 2 of theta electrical axis. Mechanical axis is equal to theta m by, theta electrical axis is equal to p by 2 theta mechanical axis. Okay, theta electrical axis is equal to p by 2 theta mechanical axis. These are the cross magnetization effect. Now let us some just graph, depends upon the graph, we need to some waveforms only. Directly we discuss the waveforms, shape of the waveforms. Okay, Okay, first distribute the armature winding. So first we distribute the armature winding. Just only distribute the armature winding. Armature winding. Distribute the armature winding. Now let us distribute the armature winding. It is shifted to competitive. Where it is? This shifted to horizontal direction. There is shifted to horizontal direction. So there is the north pole, south pole, north pole and south pole. North pole is some conductors, 3 conductors, and south pole also some 3 conductors. So we are taken to the rotation. That is the rotation of rotor. So in this case we are consisting of interpolar axis. Let us some reference axis. How many axes? 1, 2, 3 or reference axis. So they are the cross. We know the crossword and dot words. Cross and dot here. So entering and leaving the conductor. So this is nothing but the minus I by 2. So I by 2 is nothing but each conductor current for only single pole. Only it is occupies only single pole. That is we are taken to the I by 2. So here positive I by 2. Here minus I by 2. So let us next one from here and ending it here. Similarly, I by 2 minus I by 2, positive I by 2, minus I by 2. Let us third one. So minus I by 2 plus I by 2 minus I by 2. So what is the resultant? We can draw the resultant waveform. So when we can draw the resultant waveform, so minus I by 2, minus I by 2, minus I by 2, minus 3 I by 2. So next minus I by 2, minus I by 2, minus 2 I by 2. Next from in this case minus I by 2. So let us here plus I by 2. Again here plus 2 I by 2 from here. All are in positive plus 3 I by 2. So this waveform will be repeated. We can observe. So in this case, we can draw the distribute the armature winding. So these are the field winding. Now distribute the armature winding. We can draw it the distributed armature winding. So these are the shape is simply we can draw the shape is triangular shape. Whatever the distribution armature winding in the sense of note armature armature MMF is the direction is the shape is triangular shape. The shape is triangular shape. So we know the here magnitude of, let us some point, magnitude of MMF A at peak. Magnitude of MMF A at peak. So what is the magnitude of MMF A at peak? 3 I by 2. So what is the 3? We are consisting of number of conductors. 3 is nothing but that is Z. Z is equal to number of conductors. Conductors per pole. We have taken only each pole per pole. Let us we replace with 3 Z by P. 3 is replaced with Z by P. So what is the I? I is nothing but current. Each conductor current per one pole. Each conductor current in only one pole. We are taken only one pole. This depends upon the parallel paths. So like as we can write as MMF peak, MMF A peak. What is the MMF A peak? We can write as 3 is replaced with Z by P. I is equal to each conductor current. Each conductor current, that is nothing but we are consisting of parallel paths. So for example, IA by A. How many parallel paths? We know IA by A by 2. So we can write as maximum Z by 2P into IA by A. So here this is nothing but MMF A of peak. MMF A of peak, magnitude of MMF. Here the peak magnitude of MMF A. So from the case we can find out the again. So we know the armature MMF A, magnitude motive force of armature shape is triangular shape. So whatever the resultant flux shape, okay, let us okay. First we can draw the shape of these are MMF field winding. So next we can draw the already armature MMF in the armature MMF maximum at in interpolar axis. Already we discussed it. So maximum armature flux is maximum at in near to interpolar. That is nothing but this is a lead pole and tail pole tip. Tail pole tip is the maximum MMF. So now resultant. What is the armature reaction? Armature reaction is nothing but they are the MMF A. The armature reaction is nothing but both MMF A and reaction between MMF field reaction and armature reaction. In this reaction we can find out the total armature reaction. So due to this total, so we can adding up to, we can observe here armature flux in between lead pole tip to trailing pole tip. What happened? Uniform air gap. So uniform air gap armature flux is directly pi A is directly proportional to MMF A. So that is a linear condition. Up to here there is no change. It will be linear condition. Up to here linear condition. Sorry for the marker system. Linear condition. Then after at before leading, after tailing tip. After tailing tip, what happened? Length will be increased. When the armature length will be increased, reluctance will be increased, flux will be reduced. So up to from here to here, flux will be reduced. Up to interpole tip. Then after interpole tip, armature gap will be decreased. So decreased, reluctance will be decreased, flux will be increased. Again from here to here, linear. So this shape is armature flux. The shape is nothing but what happened? Saddle shape. Saddle shape. Armature flux shape. Armature flux shape is saddle shape. So now we can draw the resultant flux. They are the armature flux. Now resultant flux, what happened? So okay. So these are the armature flux is the saddle shape. We can draw the resultant flux also. So resultant flux, we are consisting of some resultant flux. So here shifted to MNA is whatever these are the MNA, but MNA is shifted to some axis. So due to here some saturation effect, here some demagnetization effect will be occurred. Then MNA will be shifted to new axis. MNA will be shifted to the new axis. Again we are connected to the interpoles. Then MNA is shifted to the back position. So this shape is nothing but saddle shape of armature flux. So these are up to we discuss the armature reaction concept. Next we discuss the interpoles. So what happened? Interpoles and commutation techniques. That is a small topic, and similarly we discuss the commutation techniques also. Compensator winding, interpoles and commutation techniques. So thank you for watching.